Hello again. It's Dr. P, this time coming to you from my office and at home, of course, and the computer, because in today's lecture I'm going to talk about the periodic table. And it's kind of hard to talk about the periodic table without actually having a periodic table to talk about. So go ahead and do that. So let me go ahead and share my screen. And here is the periodic table. Okay, Dr. P, what is that? Well, this is actually a version of one of the early versions of Mendeleev's original periodic table. I don't think it's the very first one, but it is an early one. The whole point behind the periodic table is that it organizes the elements in groups that recur periodically. This is written in German, so you've got group, G-R-U-P-P-E, group 1, group 2, group 3, etc. We're up to group 1, 2, 3, 4, 5, 6, 7, 8. And then we've got the elements here. So he put lithium, actually hydrogen, lithium, sodium, potassium, iridium, and cesium in group 1. He also has stuck in here copper, silver, and gold, which is kind of interesting. We'll get to that in just a minute. Now, some other things to note here. This J is actually iodine. J equals 127. That's actually iodine. I guess in German it must have a J instead of an I. Anyway, let's go back, I think, to this first group. And you're familiar with, of course, the alkali metals, lithium, potassium, rubidium, and cesium. And one of the things that they tend to do is they tend to react quite violently with water. Oh, sodium too, sorry. Let's add sodium in it. Lithium, sodium, potassium, rubidium, cesium. Now what about copper, silver, and gold? Those don't react at all with water. Well, one of the organizational principles behind Mendeleev's periodic table was not just how things react, but what kind of compounds they form. It turns out that, let's say, sodium and chlorine will always form a 1-to-1 molar ratio in their compound, NaCl. We get potassium, KCl. Well, also copper, you get copper chloride sometimes. Sometimes we get CuCl2, which is like copper's over here as well. We get silver chloride is always AgCl. So that 1-to-1 ratio led Mendeleev to put it in group 1. Put copper, silver, gold, that is, in group 1. Now, this doesn't look maybe quite as easy to get a hold of as, or easy to get to maybe understand as the modern periodic table. So let's go ahead and take a look at that instead. So I'm just going to exit out of that. And I'm just going to go over to, I have an announcement posted, well, as of April 6th, that's the most recent one. And it's links to different periodic tables. So you can click on these. And one of the ones I like is this ptable.com. I'll just open that up here. It's already open. And here is a periodic table. I'm going to scroll down a little bit so that we can see the features here. And of course, periodic table groups things not only by similar properties, but it also groups them on, based on quantum numbers. What do I mean by that? Well, let's select this tab up on the top here that says orbitals. And boom, there we go. Now I've got my different blocks in the periodic table are colored different colors. In the pink, we have the S block. These elements have as their highest energy ground state electrons S electrons. And so Hydrogen is 1s1. Highlight that right there in blue, 1s1. Helium is 1s2. 1s2 right there. And then lithium is 1s2, 2s1. Beryllium, 1s2, 2s2. So you can hover your mouse over these or tap on them on an iPad or something. Hover your mouse over the entries for the elements, and you can see the electron configurations right over here. So there's carbon. I'm going to highlight that in blue here. 1s2, 2s2, 2p2. And then if you want to actually see the filling that goes on here, let's do boron. I can go ahead and take a look at my little, let me zoom in on these just a little bit here. Let's do this. It's going to let me zoom in. Yeah. There we go. So that's a little bit easier to see. Now you can see with boron, I've got highlighted here 1s2, 2s2, 2p1. I can look over and see 2 electrons in the 1s orbital. And when I put my mouse over that, I see, oh, my 1s orbital is a sphere. 2s, there are 2 electrons, so 2s2, concentric spheres. And then 2p1, 1 electron in a p orbital is in this kind of 2 lobes along one of the axes. All right, so you can go along filling up electrons in your elements in the periodic table. And you could recreate the periodic table if you remember how to fill up your electrons. So, I do 1s, and 2s, and 2p, then 3s, then 3p. Then I actually do 4s before doing 3d, and then 4p. And we'll take another look at a little device to help remember that. But if you ever forget what order you want to fill up your orbitals, you can look at the periodic table. The periodic table tells you I fill up 1s first. Helium was moved over here just to lump it in with the other s, with the rest of the s block. Lithium, beryllium, boron is 1s2, 2s2, 2p1, and so on. And then I get to neon, and it's 1s2, 2s2, 2p6. And then I go back around and get to sodium, which now has neon's configuration, but with 3s1. And then magnesium is 3s2, aluminum 3p1, silicon 3p2, etc. But then when I get to potassium, I go to the 4s orbital and put an electron in there, and then calcium. And then scandium now is the argon configuration with 4s2 and 3d1. So I fill in my 3d orbitals after my 4s orbitals. Zoom back out here just a little bit. So, feel free to go ahead and play around with these periodic tables. There is a figure in the text which sort of looks like this, which shows the order of filling. So if you just wrote out 1s, 2s, 3s, 4s, 5s, all the way down, and then next to it wrote 2p, 3p, 4p, 5p, and then 3d, 4d. So all of your n equals 1, n equals 2, n equals 3, n equals 4, all lined up. And then you fill going from the upper right to the lower left. So follow them out, the cursor here. Upper right, 1s. I'm going to have to loop back around. Upper right, and we filled it 2s. Loop back around. Upper right, go down to the left, we fill the 2p, then the 3s. Up back around. Then the 3p, then the 4s, then the 3d, the 4p, the 5s, 4d, 5p, 6s, and then the 4f, and then the 5d. And this is known as the Aufbau Principle, AUFBAU, and it deals with the filling of these orbitals. Now, if you actually have orbital energies, then you could do it that way. But if you forget what your relative orbital energies are, you could draw out this kind of sort of like a slanting planting a tree or something, Christmas tree or something, but you could go ahead and do that. I did want to show a couple other periodic tables here. This one's kind of nice from Chem, and it was the last link, because if you take a look here, so I'm just going to click on beryllium, it actually gives you your electron configuration. And let's click on a different one. Let's do arsenic, why not? And notice that it has the abbreviated electron configuration. And this is a shorthand way of indicating where the electrons are. And what it says is that the electron configuration of arsenic has the same as argon, so that's brackets argon, and then 4s2, 3d10, 4p3. Okay. There's some other ones here. This one on the Royal Society of Chemistry is kind of nice because you can click here on individual blocks. So there's our S block. Notice that helium on the right is part of the S block. There's the P block, the D block in the middle, the F block, which is actually in the middle, although it looks like it's down below. Well, why is that? Well, because this is what would happen if you put it where it was supposed to go. You get a really long periodic table, which is fine if you have a bookmark, but if you're trying to put it on a piece of paper, the inside cover of a textbook, something like that, it's a lot easier to take the F block and stick it underneath. But it really goes in between the S and the D block. And you can see we fill in S, S, 2S1, 2S2, 2P, fill in the 3S, the 3P, 4S, the 3D, 4P, 5S, the 4D, 5P, the 6S, 4F, the 5D, 6P, etc. So again, you can figure out what your quantum numbers are from the periodic table, or you could recreate the periodic table from an understanding of the quantum numbers. So let me just go. So this is what the smaller one would look like here. And I think that's about all I want to say about the periodic table. But please check out these sites and play around a little bit with them. And I think if you go to p-table and click on orbitals, then you can check out the orbital filling just by putting your cursor. Tungsten is one of my favorite elements here, so I'll click on tungsten. And here we go. And now I can hover over some of these filled orbitals and see what the orbitals look like. And I can see my orbital configuration here in the boxes, arrows in boxes, or as completely written out. Now, if I was going to use a shorthand, I would say xenon, and then 6s2, 4f14, 5p4. Everything up to that last point. This whole bit up to this last point here, and I've highlighted in blue. That's just xenon in brackets. Okay. So in the workshop, when I talk about when I talk about electron configuration, I'll go over some more examples of this, and I'll probably pull out a periodic table that I can write on as such. But in the meantime, hope you guys enjoy your looking at the periodic table. And until then, I will talk with you later. Bye now.